Hello everyone, welcome to my channel. So in these videos, we will continue our topics in statistics about how to use the visualization to show our data sets characteristics. So here in these videos, I want to work on the probability plot. So for the probability plot, this is also show some features of our data. So previous we already learned the box plot, the histogram, and also the dim and leaf plot. So for those plots, generally we show some information of the distribution of our data sets. However, in this plots, this is show some different features. So this is to show some like whether the data is confirmed from hypothesis distributions of our assumptions. So for example, if we get a data set and then we say, okay, this maybe come from, this is observations of a random variable, which is follows a normal random variable or follows a normal distribution. Or if you assume like we get some data and we say, okay, maybe this is an observation of a random variable of exponential random variable. So I also remember previous when I talked about the topics about normal random variable and exponential random variable. So this continuous random variable. So students ask me like, okay, for the question I say, this is something about like a phone call arriving a service center. I say, okay, they generally follows exponential distribution. So the waiting time is an exponential distribution. So student asks me like, why you have this assumption? So the reason is like what we do here. Like we collect so many data from the waiting time for this customer service, and then we draw this probability plots when we assume the original random variable follows exponential distribution, and then we can get a conclusion like our hypothesis is correct or our assumption is wrong. So then let me explain step by step how we can, when we given data or say the sample like x1 until xn observations, then how we can draw this graph. So to do this, if we have this one, the first step is we should order our data. So for this order or say rank of the sample, in general we order this from the smallest to the largest. So that means we will denote the smallest or the minimum of our data as the x sub parenthesis 1. Okay, and then the maximum of our sample, this is actually here, we denote this by x sub parenthesis n. So this is because we have n observations. And then for this order of this data, then previous we talk about the percentile of a data. So if you haven't looked at what is a percentile, so please look at my previous videos about the stem and the leaf sections. So there I give the definition of the percentile. So after we ordered our n observations, then it's just a approximation of our percentile is the sub letter of our number here. We can use this one as compute our percentile. So here we can say if this is equal 1, this one, and if we have this or n, so we can denote this by like a number j. So then for the number x sub parenthesis j, will approximate our this x sub j parenthesis is approximate our percentile 100 times j over n. So what this means? This means like if we have, for example, if we have n is equal 10, then this means if n equal 10 and j equal 2, then this is x sub parentheses 2. This is approximate our percentile 100 times 2 over 10. So 2 over 10 is a 0.2, right? So times 100, this is about 20 percentage. You can think like this is about our percentile. So that means because here we have 10 values, and this number x sub 2 parentheses, this is the second smallest number. And if we have 10 numbers, so in other words, there is 8 numbers is larger than this x sub parentheses 2. In other words, if this is 80 numbers, 8 numbers larger than this one, overall it means 80% of the numbers among these 10 numbers is larger than our x sub 2 parentheses. So in other words, this is same with our definition of the 20 percentile here. So that's why we can use the x sub parentheses j to approximate the percentile, this value. Okay, so after we know this can give us the percentile approximation, then based on our property of the percentile definition, then we can use this one to help us guess what is the value we want to make our probability equal this percentile. This j minus 0.5 divided by n. So here, this one, the right-hand side, this minus 0.2. This is about our correction of our values. So if you look at my previous videos in probability about how to use the normal distribution to approximate the Poisson distribution, at that part we also have the use 0.5 as our correction. So here the idea is also similar. When we try to use some discrete number to approximate some continuous values, we also have a correction to including this here. So I explain more of this in that video, so please look at that video for the more explanation. So here on the right hand side, you can think like if similar idea, we have j equal 2 and n equal 10. So this will actually a number very approximate our value about 0.2. Okay, so then for this this is actually equal 2 minus 0.5 divided by 10. So this is equal 0.15. Okay, so this is what we have about the percentile. In other words, you can think this is about the value of the probability we have. And then for the left-hand side, what we want is after we give the assumption of the distribution of this random variable, then we can also use the CDF of our probability of the random variable to compute this probability. So then we can find the value of our yj here. So this is based on this yj will become our y-axis when we draw the graph of this probability plot. Okay, so the idea of this is if our assumption of this distribution is correct. So for example, if you assume this observation is from a normal random variable, then what will happen is when we draw the x-axis as our ordered sample value, and the y-axis is as the value of yj we find corresponding to our xj, then the value of this a pair of x and y should very close to each other. That means our assumption is correct. So for example here about this graph, so if now here this is our x and this is a value we found, and I use the blue point to show the data I draw here. So you can see here the black line is a straight line here. So this means based on our blue points, then this is our assumption is correct. So that means this is how we can use this graph to visualize or visually check our assumption. So to check our assume this observations is of a random variable follows a specific distribution is correct or not. So this is we use the graph to see if we see the points is along a straight line, then this is correct. However, you can know this is not a very theoretic assumption. So what this means? This means if we look at the points, so here I can see, okay, this one is just a very follows a straight line. However, if I say this is, I have some points here. So for example, I add a little more points. Maybe I use another color, like I use the red color. So the graph is blue color, have some points here, and maybe a little more here. So do we think it still follows a straight line? Maybe the answer is still yes. But if maybe some other people, maybe some people's answer is no. So this assumption, like we check is correct or answer or wrong, this is really based on how strict this person say the graph is follows all the points is follows straight line. So that means this is not a very logic accurate idea of our to check our assumption. However, why this probability plot is still very popular? Because it's easy. So when we use some software, no matter it's about Python or R or SPSS or some software like SAS, we can just import our data to the software, and they can draw this graph automatically. And when we talk about some people, like maybe they know very less of the probability or statistic, or you show this picture to your audience, no matter who they are, or no matter they from the engineering or mathematics or technology, maybe they don't know any of them, but they can look at the graph, and when you say, okay, you see this is close to the line, and they will say, yeah, yes, visually it's correct, and then it means, okay, you tell them by the statistic, we can say our assumption is correct. It's much easier than you give them like 1,000 points and you tell them, okay, we can find a rule here with a complete formula and a computations. This will looks more hard for them. So that's why this probability plot is very, very popular in the probabilities. So okay, so this is about the end of my the explanation of how to use the visualizations to show the features of the data set. So of course in these videos I didn't talk about anything about how to use the software to draw these graphs. So if you're interested in some topic like this, you can leave a comment under this video. And from next video, I will start to talk about how to compute or get the estimations of some parameters in statistic. So see you in the next video, and please subscribe this channel.